The next few questions are a review of circles. Now, I don't believe this specific example I included in our circle notes, only because it's rare and you don't see it very often. But essentially, the property states that if the diameter or radius is perpendicular to a chord, which it is because we have a right angle, then it cuts the chord CD in half. Okay, so if CD is equal to 8, the diameter being perpendicular cuts it in half. So each portion is just 4. Okay, that's all you need to know about that. Very similar to the triangles, the perpendicular bisector of a triangle cuts the base in half. Same principle. But instead of cutting the base of a circle, because a circle doesn't have a base, it cuts the chord CD in half. So each smaller piece is 4. Number 28, we have an inscribed angle. Okay, rule for inscribed angles is that the angle, in this case angle N, is equal to half of the arc created. So it would be half of LK. So LK is 62 degrees. So 62 divided by 2 is 31. So N is 31 degrees. Okay. Here you'll notice that both NL and PM have a value of 6. So they're congruent. So therefore, we can set each expression congruent as well. I didn't bother to go over this because it's really, really too simple. If each chord is congruent, then obviously those expressions related to those chords are also congruent. So when I subtract 2x from both sides, I get 4 is equal to x plus 3. Subtract 3 from both sides, so x equals 1. Again, you'll notice the two chords are congruent. JK is 4, LM is 4. So that means the arcs are also congruent. JK is 82, LM is also 82. Okay? That's why I didn't spend a lot of time on this in our circle notes, because basically everything's equal to each other or cut in half if you have a bisector. Here you're just asking to name the radii of the circle. So remember, the radius is any point from the center to the outer edge. So you have AP, CP, and PB. Or PA, PB, and PC, which is question D, or option D, sorry. Okay. Here we have central angles, because all of the angles are formed by radii, and we are told we're looking for the length of KM. DM has a measure of 9, which really isn't going to tell us much. NL, NL is a diameter. That is important. Okay, so find the length of arc KM. I don't like this question because I don't know if we're talking about K to M this way or if we're referring to K to M this way. Okay, since they don't specify, I'm going to go try to use logic here, and I'm going to go clockwise. So I'm going to follow the blue arc, okay? So to find out what that is, I first have to find the measure of the arc in number of degrees, okay? And the fact that an L is a diameter is very important because a diameter cuts a circle in half. So that means half of 360 is 180, okay? So what that means is that this angle here, because an L is a diameter, that makes this angle, and because it's a central angle, that arc 80 degrees. Okay. Now, looking from this other side here, from J to K, I have 50 and 60, 50 plus 60. So that's 110 degrees. So to find the measure of this angle in this arc, JN, I have to do 180 minus 110. And I do get 70. Okay, so remember, central angles, the arc is the same measure as the angle. So if I'm following my blue arc, okay, which actually starts here, K to M, I'm adding 50 plus 70 plus 80. Okay, that's K, L, M, N, okay? All right, so, and I should probably move the 110 because I don't want to confuse anybody. I only use the 110 to find the arc of JN because NL was a diameter. But what I'm looking for is the length of KM. So this is the same as asking about arc length because KM is an arc. So the first thing I have to do is find the total number of degrees in KM so I know what portion of the total circle I'm looking for. So when we do 50 plus 70 plus 80, I get a total of 200 degrees. So KM, the blue arc, represents 200 of the total 360 degrees of my circle. Now with arc length, again, because I'm measuring the outer edge, what I'm looking for, or the formula I'm going to use, is circumference, which is 2 pi r. And we're told that the radius dm is 9 millimeters. Okay, so this is 2 times pi times 9. So that's 18 pi. 2 times 9 is 18. And when I do 18 times pi, or 3.14, I get a total circumference of 56.52. Okay, so that's the total circumference. But I only want a portion of the circumference. So I'm going to take that 56.52 and multiply it times the portion that KM represents, which is 200 over 360. So to get my final answer, I'm going to take my total circumference, I'm going to multiply times 200, the portion of the total circumference I'm looking for, and divide it by 360, the total number of degrees, and I get 31.4. Now, of course, looking at my answer key, that is not what they wanted. They're looking for 25.13. So, let me calculate the red arc. And again, I will make sure on your final that there isn't a question as to which arc you're trying to solve. So Km, my red arc, is 60 plus 100. So that's 160 over 360. But what is nice is that the circumference is still the same. Total circumference is still the same. So I'm still going to multiply 56.52, but this time measuring Km, the red arc, I'm going to take my total circumference of 56.52, multiply times 160, and divide by 360, and sure enough, I do get 25.12. So, although the book was not specific, unfortunately, it was referring to the arc Km. Okay. Our last property, this has to do with a quadrilateral inscribed a circle. Now, because we don't know if this is a parallelogram or what type of quadrilateral it is, and it has to do with, everything has to do with, it's based off of inscribed angles and how the angle is half the inscribed arc. So what we end up, I'm not going to spend a ton of time explaining why this theory works the way it does, but essentially using, for the basis of inscribed angles, what it tells us is that opposite angles of an inscribed quadrilateral are, I'm sorry, I wrote congruent. They're not congruent. They're supplementary. So what that means is x plus z equals 180, and angle W plus y equals 180. And in this case, it's asking for W. So I'm going to do x plus 18, which is W, plus y, which is 2x, equals 180. So add my x's, so I get 3x plus 18 equals 180. Subtract 18 from both sides. And 180 minus 18 gives me 162. And I'm left with 3x, so when I divide by 3, I get x is equal to 54. Okay? But that's not what it asks for. It asks for the measure of angle W. Well, angle W is x plus 18. So what I'm going to do is 54 plus 18 to find the measure of angle W, and when I do that, I get 72 degrees. Our last two questions deal with the equation of a circle. Equations of circles are, I will give you the equation, but essentially what it is it's x minus h squared plus y minus k squared equals r squared. Okay, and so with the center, so HK represents the center. Okay, so I'm just going to plug in 5 for h, so it's going to be x minus 5. Oops, that's not where I need the extra parentheses. X minus 5 squared plus y minus a negative 2 squared. and two negatives are going to give me a positive. So I'm going to end up with y plus 2 squared. And if you were given the radius, which I'm going to be, since all of them are 5, okay, the equation tells us we have to square the radius. So my radius is going to be 5 squared. The problem is that, and that's a pretty good assumption, but unfortunately it doesn't give us the radius in this case. So what we have to do, it says it passes through the point 4, 0. So what that actually requires us to do is find the distance between those 2 points. Our question, 5 squared, if I was to square 5, I'd get 25. And that's not our answer. That's not the length that we got. So we're actually just replacing, because I'm just substituting in the 5 for the radius. So my answer is actually B. So be careful. I made an assumption assuming that 5, just by squaring 5, would tell us what the radius is, and in which case I was incorrect. We actually had to take the time to find the distance between the center 5, -2, and the point the circle lies on, which is 4, 0. Okay, so here it's asking us to state the center and then the length of the radius. Now remember, let's keep this formula here in mind, okay? So when your value is positive, we just plug it in, so it ends up being -5, because that's what because there are subtraction signs in between the x and h and y and k. So both of these signs are negative, so my center is just going to be 1, 4. Okay? If for some reason we had a positive, like we did here, then our coordinate would be negative. So the signs are actually kind of opposite. And because, since the squared that we normally have here isn't listed, the squared isn't there. So what that means is that 9 is already squared. They squared the radius. The radius squared is 9. So remember, the opposite of squaring a number is to take the square root. So the square root of 9 is actually 3, because they already squared the radius. If they hadn't squared it, this would have instead said 3 squared, but they simplified that to be 9. So my radius is actually 3. So we've got 5, 2, and 4, 0. And you'll notice, wow, these are pretty tiny. This is 2 by 1. And so we're looking for this right here, because the circle comes around this way. So we're looking for that radius. The center of the circle was here. So using Pythagoras' theorem, 2 squared plus 1 squared equals my radius squared in this case, because C represents our radius. We get 4 plus 5 equals C squared. I'm sorry, 4 plus 1. 1 squared is 1, so 4 plus 1 is 5. 5 equals C squared. So when so technically the length of C is the square root of 5. So when we go back, I have C squared is equal to 5.